Hi everyone. Today we're going to start looking at a new topic. As we wrap up scatter plots, we're going to start looking at bearing problems. And in order to do bearing problems, well, we need to be able to read bearings. So north 30 degrees east. This tells me I should head north first and then veer 30 degrees in this direction. So if I were to draw that, I'd start by drawing a compass rose. Remember, north, south, east, west. And I would head north, but then I would veer 30 degrees to the east. That's a bearing of north 30 east. This is where I head if my bearing is north 30 east. How about north 70 west? Well, in that case, I'd be heading north still, but this time I would go 70 degrees to the west. We know that this is a right angle every time we draw a compass rose, and so I'm saying 70 degrees is most of the way across that quadrant. We don't take out a protractor and measure this. I don't expect you to. But you'll notice that I'm just drawing approximations here. Okay, how about south 40 degrees east? South 40 east. Well, that means we're going to head south first, and then we're going to veer 40 degrees to the east. And south 60 west. We'll start by heading south again, but this time we'll go 60 degrees towards the west. This is the bearing we follow if our heading is south 60 west. Normally, north and south come first and east and west come second, but not always. Sometimes we could have east or west first and then north or south second. For example, east 63 degrees north. That means I'm going to head east first and go 63 degrees towards the north. Now this bearing, east 63 north, is the same as head north and then go 27 degrees east. Notice these two add up to 90 degrees. Either bearing can be used to describe this path, either east 63 north or north and then 27 east. So how about west 20 north? West 20 north. So if I head west and then I veer 20 degrees to the north, my path looks like that. This is the same as if I had headed north and then gone 70 degrees to the west. You can use either one, I don't care, but if you're presented with this, you should be able to draw that, and if you're presented with this, you should be able to draw that, and you should know that these are equivalent vectors. I'm either heading west and 20 degrees north, or north and 70 degrees west. Okay, so how does this come into our math class, these bearings? Well, the bearing problem sounds like this. You head south 52 degrees east for 7 miles, then turn north 38 degrees east for 24 miles. And then we'll ask two questions. The first one is, how far to get home. And the second question is, on what bearing? Okay? So, let's take a look. We're going to head south 52 east. South and then 52 east. And then at this end, we're going to go for 7 miles. And then we're going to come to this point where we're going to go north 38 east. North 38 east. Because we headed north and then 38. This is 24 miles. So here's home. Here's where we are now. And our questions are, how far is it to get back home? And on what bearing? South something west or west something south? All right, well, so we need to answer both of those questions, but before we do, I want to point something out. These compass roses are useful and important, or at the very least, important. And the reason why is because they create parallel lines cut by a transversal. And so this 52 degrees, well, this is 52 also. And notice that when we add that first bearing, 52, with the second bearing angle, 38, we get 90 degrees. It would surprise me if in any of these bearing problems before we get to chapter 6, this angle didn't add up to 90. This should always be 90 degrees, or you've done something wrong. Okay? All right, and the nice thing about this being a 90-degree angle is that this is a right triangle. And if this is a right triangle and this is 7 and 24, there's a good chance at this point in the year that you know this is 25, or you know you could use the Pythagorean theorem. 7 squared plus 24 squared equals the distance home squared. 49 plus 576 is distance squared. And so we get 625 is distance squared. So the distance back home is 25 miles. 25 miles to get back home. So that'll be the easy question. How far to get back home will always be this Pythagorean theorem. Sometimes it'll even be a Pythagorean triple. Now what bearing? Well, this is a little more complicated. We're either going to head south this many degrees west, or we're going to head west this many degrees south. And I feel like I don't have enough information over here. I know that this is 38 degrees, and therefore this is 38 degrees, because again, parallel lines cut by a transversal form alternate interior angles. But notice that our bearing would be south 38 and this angle here. This one that's inside of our triangle. This angle. If I add 38 plus that angle, I can get my bearing home. Well, how can I find that angle? Remember, that angle is this one. And that's inside of our triangle. And notice we've got opposite and adjacent. So I could say tangent theta equals 7 over 24. And then if I take the inverse tangent of both sides, I could solve for theta and find out that theta equals, let me pull out my calculator, inverse tangent of 7 divided by 24 gives me 16.260 degrees. Remember, we're always rounding to 3 decimal places. So we figured out that this angle here, inside the triangle, is 16.26 degrees. And this angle came from our second bearing, 38 degrees. So if I add 38 degrees, I'll end up with 54.260 degrees. So this whole angle is 54.26 degrees. That means I want to head south 54.260 degrees west. Or, having figured out that this was 54.276, I could subtract from 90 minus 54.26, and I get 35.74. And so I could say west 35.74 degrees south. Either one of those would be a correct answer to this problem. Okay? I think we should do another one of those. I also just want to be clear that the way we draw and understand this, these pictures, definitely has an effect on how we describe bearings. So if I know that this is 20 degrees, and this is B, and here we have A, and this is 20 degrees. What is the bearing from A to B? That means I'm at A and I want to get up here to B. So I'm going to head north and some west, 20 degrees west. North, 20 degrees west. But if I want to go from B to A, if I'm here and I want to go back this way, then I need to head south and 20 degrees east. This may seem really obvious to you, but a lot of people on the next assessment get the problems wrong because I'm asking for this and they give me this. I'm asking for this and they give me this. Or I'm asking for this and they give me that. So please be mindful of your bearings, okay? All right, so let's do one more bearing problem. And then I want to bring up a sort of nightmare situation that comes up. Okay, let's head north 42 degrees west for 20 miles. And then we'll head south 48 degrees west for 28 miles. Okay, so what's that going to look like? We're going to start by heading north 42 west for 20 miles. And then, at that point, I draw another compass rose because I'm going to turn south 48 west. Now remember, to aid your drawing of these things, you know that this is 42. You know that south 48 means this is 48. 48 plus 42, these should add up to 90 degrees. So when you're drawing this, draw that 90-degree angle. And this is 28 miles. Okay? So here we are, and we want to talk about getting back home. And we want to ask those two questions. How far is it to get back home? Well, again, I'm just going to use the Pythagorean theorem to find the distance home. I'll say that that distance squared is 20 squared plus 28 squared. And so the distance home will be the square root of 400 plus 28 squared is 784. And when I take the square root of that sum, I end up with the distance home is 34.409 miles. So this is 34.409 miles back. Okay? That's pretty straightforward. But on what bearing? So I draw my compass rose where I am, and I notice that my bearing home is north that much east, or east that much north. Okay, we know from alternate interior angles, if this is 48, then this is 48. I'm going to use theta. Theta is the angle inside of this triangle. Let me highlight it in red for you. Inside this triangle, we've got a theta, and I can use tangent. Tangent of theta will be 20 over 28. So if I take the inverse tangent of both sides, I can find that theta, inverse tangent 20 over 28, on my calculator, turns out to be theta is 35.538 degrees. So this is 35.538 degrees here. My whole bearing angle is this 48 plus theta, plus 48. So if I add 48, I end up with 83.538 degrees. So I can either head north 83.538 degrees east, because then I'm going to head north but veer east this many degrees. That's 48 plus the 35.538, because theta was 35.538 because of inverse tan. Or I could say, well, I know that if I take this angle away from 90, I'll get only if I do that properly, I'll get 6.462 degrees. Now, what would the bearing be? Well, I would be heading east, and then I would go 6.462 degrees to the north. This is the more common answer, but I would accept either on a test. We'll be doing a lot more bearing problems in the near future. You might want to practice with these two a little more, just to get comfortable with them. Okay, now let's take a look at this nightmare vision. So we want to consider south 80 degrees east, 15 miles, and then south 10 degrees west for 30 miles. Okay, so I've seen this problem drawn lots of different ways. First way I've seen it drawn is this way: south 80 east for 15 miles, and then they draw the compass rose here, and they go south 10 west for 30 miles. This is 10, this is 80. They have their right angle here because this is 80, so this is 10, and this is 10, so this is 80. So we get a right angle there. Now, I can use the Pythagorean theorem to find the distance home. That's not the issue. The issue is, look at the bearing. Well, I head straight north to get home. North. No east or west at all. This is very strange. But I've also seen this picture drawn this way, where I had south 80 east for 15 miles. So that's 80. That's 10. And then I've seen 10, 80. I still have my right angle here. But this student says I have to go north, somewhat east, to get home. And still, I've seen a third student draw this picture this way. They also head south 80 east for 15 miles. They draw their compass rose, and then they go 30 miles. This is 10. This is too steep. $30 miles. And that brings them to here. And so for them to get back, they need to go north, something west. So isn't that interesting? Depending on how I draw the picture, I could end up in this situation where I go straight north home, I go north and something east, or I go north and something west. Well, it can't be all of these. So here's what I want to say. I want to say a couple of pieces of advice before we try and figure out which one of these is the correct drawing. First, I want to say something about these angles. You know, I said this was 80, but that doesn't make it 80. It's probably more like 50. And because this angle is off, that's going to throw off all the rest of the things in this picture. An 80-degree angle is most of the way, not merely some of the way, from south over. That's not south 80. This is much closer to south 80. But I haven't drawn that in these pictures, right? I was being kind of casual. And because I was being kind of casual, I've got this situation that comes up where I've got 3 different bearings home, and only one of them is correct. So let's imagine, first of all, it's never that one. So just don't even imagine it is. It's always one of these because we want to practice our bearings. So this one reminds me of the ones that we've been doing, the last 2 examples I did. So let's use it and see what happens. Okay, so I know that this and this are parallel, cut by a transversal. So I know that this and this are supposed to be the same. So that's supposed to be 10 degrees, which means my bearing home is even less than 10 degrees, if this is the correct picture. Okay? Well, how can we figure this out? Well, I need to find theta. Theta is this angle inside the triangle. If I subtract theta from 10, I'll get my little bearing angle. Well, let's find theta by doing inverse tangent. We know that this is 15 miles. We know that this is 30 miles. So if I say tangent theta is 15 over 30, then theta equals inverse tangent of 1/2. When I do inverse tangent of 1/2, I get, theta is 26.565 degrees. Well, wait a second, if this angle is 26 degrees, and this has to be 10, this is already bigger than 10. And guess what? That's the indication that this is not the correct picture. Because when we solved for the angle inside the triangle, we got 26.565 degrees. This angle here is the same as that one. If this is 10, then this is 10. And so then this bearing angle home is the difference between the two, between the theta, 26.565 degrees, and the alternate interior angle, 10. So my bearing home will be 26.565 minus 10, or 16.565 degrees. North, we'll head north, and then we'll go 16.565 degrees west. Wow. So, be mindful of that. That's something to pay attention to. You might be wondering how we could know it wasn't this one, because that seemed awfully enticing. If we do the inverse tangent thing, remember our theta was 26.565 degrees. This is 90, this is 80, this is 26. 90 plus 80 plus 26, no, that's not a triangle, so this won't be our choice. This ended up being our choice in this problem, but sometimes this will be the choice. So I'll just say, when you find that theta, you need to pay attention to, geez, is theta plus the 10 degree angle, or is it theta minus the 10 degree angle? And that will help us figure this out. I don't expect you to be at all pro at this. You probably won't even be comfortable with bearing problems yet. But like I said, over the next few days, we'll do a whole bunch of them, and you'll get better at them. Okay, and don't worry, in Chapter 6, there's even more bearing problems. So we can't just hide from them and pretend they'll go away. The last problem I want to do is a problem that we encountered first in Chapter 4, in the first half of Chapter 4, and it came with a picture like this. And so here we have the Burj Khalifa. That's the tallest building on the planet. Actually, we're talking about it going way high. It's 2,717 feet, actually. We have this scenario. We're looking at a point where there's someone waving from a window in the Burj Khalifa. And we see them when we're here, driving towards the building. And to look at them, we have to look up with a 2-degree angle of elevation. And then we drive for 10 miles. And now when we stop and look up at the people who are waving to us, the angle of elevation is 8 degrees. And what I'd like to know is, how high up are they? I'm trying to figure out what floor they're on. Now, when I do this kind of a problem, I'm going to need to know something about this. I'm going to call that distance x. Okay? Now, how many triangles do we see here? Well, hopefully you see 2 right triangles. You see this one, and we can write a tangent equation for that one. Tangent 8 equals h over x. But hopefully you also see this big right triangle. And we can write a tangent equation for that. Tangent 2 equals h over x plus 10. Opposite is still h, but now the adjacent side is not just this x, but this additional 10 as well. Okay, so I'm trying to find h. But I notice I've got 2 equations and 2 unknowns. That's a system. And I find here, with these problems, that I like using substitution to solve these systems. I'm going to start by clearing out the fractions. I'll multiply both sides by x here. And so I'll have x tan 8 equals h. And here I'll multiply both sides by x plus 10. And so these will cancel. Here I have to remember to distribute x tan 2 plus 10 tan 2 equals h. Notice now both of these equations are equal to h. So I can set this equation equal to this equation. Let's do that now. X tan 8 equals x tan 2 plus 10 tan 2. Okay, I notice there are x's on both sides. So I want to move this over here so I can get all the x's on one side. And no, x tan 2 minus x tan 8 minus x tan 2 is not x tan 6. It's x tan 8 minus x tan 2 equals 10 tan 2. I can't do that subtraction. What I can do is factor out an x, leaving me tan 8 minus tan 2 equals 10 tan 2. Notice how all this stuff is attached to the x with multiplication. So if I want to get x by itself, I have to divide by tan 8 minus tan 2. I'm going to ask you all to take out your calculators now so that we can make sure that you can type this into your calculator properly. X equals 10 tan 2 over tan 8 minus tan 2. And don't forget, these are degrees. So your calculator needs to be set in degrees. That was true in the bearing problems as well. When we're doing graphing scatter plots, our calculator is in radians because we're graphing trig functions. But these right triangle word problems, they're all going to be in degrees. So set your calculator in degrees if you haven't already, and type this in. 10 tan 2 divided by, remember, everything on the bottom has to be in parentheses, tan 8. Now notice when I've got tan 8 here, it opens a parenthesis for me. I'm going to have to close that parenthesis before I subtract tangent 2. And then I'm going to close two parentheses. So I end up, of course, with an error. What's my error? Oh, I've got two subtraction symbols there. One will be sufficient. Parentheses, second, insert, subtract. Okay, I get that x equals 3.3062622823 miles. That's this distance. And please make sure you got that number. This is a complicated thing to type in. And if you can get all this way to this point and then get the problem wrong because you didn't type it into your calculator properly, you will be sad and I will be sad. So let's not be sad. Pull out the calculator. Make sure you're typing this in with the appropriate parentheses. Okay, now we just found x was 3.30626 miles. But remember, we're looking for h. Don't forget, though, you have this nifty equation called h equals x tan 8. We just found x, so if we multiply our x times the tangent of 8, that will give us the height. H equals x tan 8. So I'm going to multiply that x value by tangent of 8, and I end up with 0.4646649,368 miles. Now, that's about half a mile. If I multiply by 5,280 feet, I'll see that that's h is 2,453.43 feet. And the Burj Khalifa, it's about 17 feet to a floor, and so when I divide by 17, I end up with someone waving to me from the 144th floor. Okay, these right triangle problems that use systems will also be common for us moving forward. Please note we made one equation for this small triangle, small right triangle, and another one for the big right triangle. We then used substitution to eliminate a variable. Here we eliminated h, which is actually the thing we're trying to solve for. But it made it really easy for us to set one equation equal to the other. We moved all the x's to one side, we factored an x out, and then divided by the stuff that was left over so that we could have x by itself. That gave us the value of x, which was not our answer. We had to remember that the height was really x tan 8. So we took that x value and multiplied it by the tangent of 8 to get the height. Okie doke. Well, that's what I have for you today. Enjoy your 25A worksheet, and I hope you have a wonderful spring break. Take care, everyone.